and welcome to the ALCTS webinar, Really Mystified, Creating the Chemistry Sudden Selectors Guide. I'm Carrie Cassio, Chair of the ALCTS Continuing Education Committee. Our presenter today, Beth Brown, is Scholarly Communications and Library Grants Officer, Chemistry, Physics, Mathematics, Material Science Liaison at Binghamton University Libraries. Beth will talk about her experiences putting together the Sudden Selectors Guide to Chemistry Resources, and will give advice on being a new selector in an unfamiliar subject area. If you have questions for Beth, please type them into the question box on your screen, and she'll pause occasionally for questions. Also, please note that today's session will be recorded, and you will receive an email with a link to the recording as well as the slides shortly after the conclusion of the webinar. We don't currently have a chat function in the GoToWebinar software so that you can talk to other attendees. But if you like, please use the Twitter hashtag ALCTSCE to talk further about today's session online. We will not be monitoring the Twitter feed during the presentation, though. There may be a slight delay as I now turn the presentation over to Beth.
Okay, hello. Can you hear me? I see my volume is working. I am Elizabeth Brown, and I am, as I said before, I work at Binghamton University, which is in upstate New York, and I handle different subject areas in physical sciences. And I also have been the Scholarly Communications and Library Grants Officer for about 4 years now. So, as I'll talk a little bit more about how my roles have evolved and how this guide has evolved. But before I do that, I'm going to thank ALCTS for hosting the event and letting me give this presentation today. So I'm going to go to my next thing here. I have a short poll that I've created, and I was going to go ahead and launch it. And I wanted to get some feedback from the attendees here before I say too much more. And I wanted you to tell me, or answer the poll and say which collection areas you manage. And let's see, I just opened it, and there are some different categories here, basically chemistry if you are collecting in that area, and then some other areas of the sciences that if you're not a selector in the sciences. So I'm seeing some chemistry selectors, and it looks like, I'll give everyone a couple more seconds to answer. Okay, so it looks like most people, I'm going to close the poll. It looks like the majority of you are either in chemistry or chemical engineering, and then the remainder are in other areas of the sciences, and that no one is outside of the sciences. Okay, so that's good to know. I'm going to go ahead and close that. And then I'm not sure if everyone can see the results. I'm going to go ahead and share it so people can see. And so you can see the results. You should be able to see the results on the screen. So hopefully some of these things you will know, or some of these things you won't know. Let's see, I'm going to go on to my next. There. So there's my next slide. So I'm going to talk in this next 40 minutes or so about how I got started with this project and how it evolved over time. It didn't happen really quickly. I'm going to next show some highlights from the guide, some lists and some online sources that I found useful and that I think would be useful for a new selector. I'm going to share some of my perspectives with selecting materials, and I've done this in quite a few areas of the sciences over the years, so I've honed it over time. And then the last section, which is not really in the book as much, or the guide, as the other material, what's on the horizon for chemistry collections? Because I think chemistry is an interesting subject in that it isn't following some of the same trends with scholarly communications and, say, how people are sharing information. So I think we'll see some things a little bit differently in chemistry than, say, other areas of the physical or life science. Okay. So a little bit about me. I don't know if any of you have seen me on various social networking feeds or have been to any other talks I've given. I've been a chemistry librarian since I started as a librarian in 1998. And I have 2 degrees in chemistry. I have an MS and a BA. I also have been doing other subjects. I mean, I've been doing math and physics for a long time. I also started with geology, so I know a little bit about that as well. I've also stepped in and done other temporary selecting duties here at Binghamton in engineering. I'm trying to think, nursing, and I think about the only area I haven't done on that list is biology. So I've done quite a few things. I served as a manager for a couple of years before I became the scholarly communications librarian. And like I said, I was a former chemist. I did do some lab work, although I studied physical chemistry, and I studied more. I wasn't a structure chemist. I was more of an equipment chemist. I did more, ran a lot of experiments on machines. And so some other little pictures of me, if you've seen me on Twitter, I also have some SlideShare and Friend Feed. I don't know if any of you are familiar with those sources. I've had a blog for about a year or so. It's currently not active on the site where it is, but I can send you a link if you're interested. And I'm also active in the PAM division of the Special Libraries Association. And I'm a member of the American Chemical Society, and I've been active in the Chemical Information Division of ACS, which I'll talk a little bit more about later on. Okay. So that's a little bit about me, probably a little more than you want to know. But the guide, I'll talk a bit about how that evolved, because that happened a while back. I first talked with Bob Nardini, who was our rep at YBP, who has now moved to Foods. And he had mentioned the series to me, and then I heard from someone from ALCTS, and then I prepared a proposal for the guide, which was accepted. When I originally submitted the proposal, it included chemical engineering as well as chemistry, but I quickly found that that would make a kind of an unwieldy guide, because we don't have a chemistry and a chemical engineering program at Binghamton, and so it would be harder it would have been a lot harder for me to write that piece of the guide. So I just focused it on chemistry. I wrote each chapter one at a time, which each chapter was approved by the ALCTS committee that was handling this project. And then, let's see, the final manuscript was accepted in 2009, 2010, and then it took a little while for the final edits to get done. And then the guide was published earlier this summer. So it took a bit of time. And I would say this took longer than, say, the average book gets published. I talked a little bit about the editorial process. The process was, each chapter was approved by the committee, and then the manuscript was approved by several committees. So it went through a fair amount of review and analysis throughout from beginning to end. And then there were some final edits, which I just noticed when I was going over the guide when I got my final copy. So there have been a little bit of changes over time. And so one of the reasons why this took so long was partly the series was new. I think I was one of the first people they contacted for these guides. I think since then they've expanded, and there's more subjects that are being represented. As you can tell from last week, there was one on biology. The first guide was on business resources. I know there were other areas that they were developing as well. Part of the reason, too, was my job changed. When I started this, I was a subject librarian. I was not a manager. I quickly became a manager not long after this project was approved, and then I moved on to scholarly communications. So as those things happen, it's harder to keep track of these writing projects. So in some ways, the length of time has been good, and that collection development and collections have changed a bit, and physical collections have changed for chemistry and sciences quite a bit since 2005. So I tried to present some of those kind of institutional memory types of information for chemistry and science resources. So a new selector might get an idea of what kinds of materials they're not necessarily seeing in their physical collections. One piece of advice my first boss gave me in libraries was, don't be afraid to go into the stacks and look at the books and put your hands on the collection and really take a look at it up close. And unfortunately, because a lot of libraries are being physical collections being downsized, it's really hard to do that now. We've got a lot of books in off-site storage facilities where they've been scanned into digital collections, or they're only available for rental or through an ebook checkout type of system. So it can be hard to really get a sense of the scope of what you have. So some of these tools are with this in mind. So part of another thing I'd like to say about how this guide happened, and this picture here is a representation of that, is that the writing a guide and writing a selector's guide can be difficult. It's hard to figure out what to include, what you think people already know or don't know. So it took me a little bit of time to determine the scope of the project. Okay. So another challenge I had with this, and this is a picture of my daughter, who is apparently quite bored with something she's hearing, is that chemistry is not always an interesting subject for someone who's not a chemist. And this quote from Dennis Rodman, which is not very informative, it shows he doesn't know much about chemistry. So I think you want to, and what I tried to do was try to make these materials interesting for somebody who may not be a chemist, or who may not understand exactly why something would be important to a chemist. Okay. So some other reasons, some other challenges I had with this guide were that a lot of the guides and the existing chemical information books that were out there, some of them were very dated. Some of them came out before the internet, even in the early 1990s. So while they're very comprehensive and they're very useful, they're not always very helpful for selection or for buying things. They're really good for searching, but not necessarily for the purpose of this guide. So I tried to incorporate selection development into this particular guide because it was really targeted to that. And I also wanted to include things that were free, because there's a lot of things in chemistry that are not free, and most of you are aware of that. And then also incorporating some of the newer social media tools that were coming out around the time this guide was approved, and then targeting it to someone who was not a chemist. Most of the guides I've seen, and if you're a chemist, you've looked at, they're very specific. In fact, they're not even really targeted to chemistry librarians. They're many times targeted to working chemists in the lab. Okay, so now I'm going to talk about some of the highlights from the guide and hopefully show you some things that I think are interesting and that are of value in the guide. Okay, and so they're focused on three main areas. There are tools that were developed in the chemistry library community, which are very useful, some of which are not new but are still relevant today. So I'm going to highlight some of those. I'm going to talk about some collection tools that I found to be useful. And I'm also going to show you some of these newer web tools or social tools and other ways that you can get information for collections. So I'm going to talk about the community contributions first. And so most of you have some experience with chemistry, so you're probably familiar with the Chemical Information Sources site at Indiana University and the ChemInfo listserv, which is managed at Indiana. I would say that is the most comprehensive site that's managed by the community at large for chemistry. And I'm just going to make sure I have my notes here so I don't forget what I want to say. Here. And so the listserv was developed in 1991, and it has there's a lot of people on that listserv that are not librarians. Some of them are chemists that are interested in chemical informatics and chemical information sources. A lot of them are vendors, and of course there's librarians. So because of the nature of that community, it is quite broad, and it's a little bit more, I would say it's a little bit less librarian-centric than, say, some other library listservs or information listservs that you might come across. In most cases, it's there as a reference resource, obviously, if people need to find information about a certain tool, but there's a lot of good collections information in there, too. Some librarians post about, okay, beware this specific book. There's some issues with it. You may not want to purchase it for your collection. There's also talk about when there's new versions, new guides for the literature. If there's new tools for the literature, they will be shared on that listserv pretty readily. There's also a book source that's come out from Wikibooks that superseded the original website, the Chemical Information Sources Wikibook. And I would say that that's also a good comprehensive source as well. I did want to add that Gary Wiggins, who's now retired, and now Brian Winterman, they managed, Gary Wiggins created a lot of those sites, and Brian Winterman manages that today. So another source I wanted to mention is Thermodex, which is at the University of Texas at Austin. And this is an example of a tool that was created before ebooks, before some of the more sophisticated searching tools. The idea was basically to take print books in the collection and then find relevant properties and types and categories of chemicals, and then find, develop a tool to find them. And so these screenshots here are just showing you what you can search for and then what you would get back. But what's great about this source, I mean, certainly you can do that to answer your property questions. You can also do this to help as a collection development tool. You can put in some sources and categories and then check and see if those sources are in your collection, or you can also, look more comprehensively to see if there's things that are on this list that you don't have. So, while it's good for finding things, it's also good for developing your books. Now, I also wanted to add, when I was a library student at the University of Texas at Austin, I did add some of the entries for this as one of my student projects. So it's been around for quite a while. Okay, so the next source I wanted to talk about is there's a couple of printed, and there are more guides to these print handbooks available online. But William Armstrong at Louisiana State University has developed some very comprehensive print guides to both the two main handbooks in chemistry, the Beilstein Handbook and the Gemalin Handbook. Beilstein covers organic chemistry. Gemalin covers inorganic chemistry. I have the Beilstein one on the screen here. And what's nice about these series is they're fairly comprehensive to search the print guide, but they also have some really nice tools in here to show you the organization of these handbooks. Since they were originally published in German, and if you have a print collection of these, it can be hard, especially if you're off campus and you've stored them off campus, to look at the call numbers and figure out, okay, these abbreviations mean this is volume 25, section 4, and this is the date range that it covers. So this chart is very useful. And also there's some terms that are listed here, common chemical terms that would be in the German text of the print handbook, and then some other conversions between German and English terms. So while you may not necessarily need to use that for Beilstein, there's a lot of German in the chemical literature, and this is a good conversion tool, a good handy way to find that information. Okay, the next tool that I want to show was developed at Duke University Libraries. And this is similar to Thermodex in that it's taking properties and it's basically creating a little encyclopedia of properties listed alphabetically with the sources. And so I have the sample for the letter L. So for luminescence, you can look at the source that's listed there. So this is another great collection development tool to see if there are things in your collection that you might want to buy. I mean, one caveat, of course, is if they're older sources, they may not be in print anymore. But certainly if you get gifts or if you get other things coming into your library, you can use that to help you with the selection. Now I believe this was originally developed by Kitty Porter, who's now at Vanderbilt University. And it looks like the current subject librarian there is Megan Gansky. And so the last community source, or one of the last community sources I'm going to show you, is the ACS Division of Chemical Information. I don't know if any of you are members of this Division of Chemical Information. If you're not solely devoted to chemistry, you may not be. But one of the nice features is just like the listserv for ChemInfo, the professional group for ChemInfo, as they call themselves, is not just librarians, but chemists that study online structure determination, chemical informaticians who study chemical informatics, and other related areas. So you're going to see a wider variety of talks and presentations than you would at, say, a library conference. And their meetings are held, with the American Chemical Society, so you can also, they'll be right next to sessions on chemistry talks. And so on their website, they have a bulletin they publish. There is meetings information with presentations from past meetings. Some of the more recent meetings have also been saved as screencasts, so you can go in and listen and watch the slides. It's pretty much as if you were there at the conference. So if there's information about instruction tools, some of the new ways of searching tools, they're going to be highlighted in these meetings. So let's see. So I think that's pretty much what you can say here. And then for the last group I wanted to mention is the SLA Chemistry Division. The Special Libraries Association has an active division for chemical information. Their programming, in one of the boxes here at the bottom, you can see there are sessions, continuing education courses on learning more about chemistry information, and obviously there are sessions from the meeting that you can usually get presentations from as well. And they've also developed some other additional sources to help with selection and other areas of being a chemistry librarian. They have an information competencies for chemical information that's in its second version now, which is now published as part of the wiki. So if you do become a chemistry selector, there are a lot of places where you can get help. So now I've shown you some of the community sources, I'm going to show you some of the highlights from the book that I think make it useful for, really anybody studying chemistry or using, selecting for the first time. One of the things I wanted to do was try to collect a lot of the most important monograph series in chemistry, because chemists tend to buy a lot of books in monograph series, and there's a lot of them. This is a sample page from the book, and it shows these series organized by the different presses. So if you wanted to say, okay, what are the book series from Oxford, from the Royal Society, from the American Chemical Society, from Springer, and so forth, they're collected here in one of the chapters. And to go along with that, chemistry is very focused on journals. I also wanted to provide some kind of tool to help people if they were just looking at a new collection. Okay, what are the most important journals I would need to have for, say, organic chemistry, for inorganic chemistry? I have nanoscience here on the page on the screen. So what I did was I collected these sources from the top impact journals from Web of Science. This was in the 2008 edition. And I also intermixed that with the journals from the ACS Committee of Professional Training and Development. And that group creates this recommended journal list, and they have a list of top journals and highly recommended journals for chemistry collections. This is part of the ACS certification for having a Bachelor of Science in Chemistry. So they will monitor your collections if you have a certified program. If you're not sure if your department has a certified program, I would contact the chemistry department, and they should know, because the paperwork for that would come to that department directly. So like I said, these lists are interfiled. So say for nanoscience, there's a code here. So if it has a asterisk, it's on one list. If it's in italics, it's on another. And so you can see from nanoscience, because it's a newer area, that professional development list doesn't have as many, for the ACS doesn't have as many things on it as, say, the Web of Science and high impact factor list. So you do need to check multiple sources to get a good idea of what are some of the best journals to have for your collection. I broke this up into the subdisciplines because in most cases the faculty you're going to be working with are going to be focused in one or more of those areas. And that's how they're going to think about the journals. And so, of course, you can use it for when new people come. You can also use it when you're doing a serials review. There's different ways you can use this list. And so the last thing I wanted to highlight from the book, and I scanned these from the book, just these few pages, is listing some of the preprint sources where you might find early versions of papers. So this is a little blurry, but these are some of the main sources. One of the problems is chemistry doesn't have a centralized preprint server like, say, the archive.org for physics, and few chemists really may take advantage of the preprint server. So you're probably not going to see a lot of these out there. You're much more likely to see a faculty member putting a link to one of their articles on their website and putting it out that way. And one of the ways that scientists can do that is that the ACS will allow them to put a link like that on their web page and then allow them to send up to 50 preprints for an article. So some of the publishers have that mechanism built in for a faculty member to do that. Okay. So those are a few of the things for the guide that I created, and I'm going to talk about some of the web and other social tools because those were really coming into prominence, at the time I was writing the first version of this manuscript. And so one of the areas that is nice is that there are more tools available on the web for chemists to use to get their research done and to search and to find things. One of the tools that chemists use a lot are structure drawing tools, and this is just sort of a smorgasbord here of some of the most important ones. I mean, most chemistry departments have ChemDraw as their main structure drawing tool, and they may have a contract with ChemDraw through the department. But one of the things you might come into contact with as a selector is they might want the library to be involved in that in some way, either negotiating a license, helping to provide a platform to download a version of ChemDraw. So that's something you might want to keep in mind as a sudden selector. You may get thrust into this arena of structured drawing tools. There's some other free drawing tools besides ChemDraw that you can use as well. The Marvin Suite is one, which I have on my computer. There's another kind of homemade structured drawing tool, the JME source that I have here. And then Symixdraw was an earlier version of the drawing tool that was used in the online version of Beilstein Crossfire. So if you keep, if you become a selector, you will most likely have to deal with structured drawing tools at some point. Okay, so the other thing you may have to deal with is a selector, which you may never see in other areas of science, or spectroscopy sources. And so there are sources available for free online. A couple of these I've shown here on this slide. There's the NIST webbook, which is the UV visible spectrum on the left-hand side. That has a lot of property sources, but it's not a huge number of substances, so it's a fairly small database overall. There's another openly shared and created database for NMR spectra. NMR spectra are nuclear magnetic resonance spectra, where they use a magnet to flip the electron spins. So for these NMR spectra, scientists have shared about 50,000 of these spectra online. And there's a link to the site below. But more commonly, you're going to find spectra online through licensed resources. And one example of this is the Know-It-All spectra collection from Biorad, which used to be in these green binders. We still have some of them in our library. They were from one company that created a whole bunch of these spectra in the 60s, 70s, 80s. They're very comprehensive. Some of them are not very high resolution, but for some of the types of spectra people want to find, they're very useful. So, I would recommend talking with your department if you find yourself in the position of trying to select online licensed spectroscopy sources, because you do want to make sure, for example, that it's spectra that they're actually going to be wanting or needing to use in their research. Because there's many, many different types of spectra. The NMR and the UV spectra that I have here, they're just two examples. So another advantage of chemistry, while the materials are very expensive, most of which you've probably noticed if you've become a selector, the vendor support and the online resources available for sharing with faculty, for determining what you need to buy, is very, very good. Chemical abstract sources the ACS, the American Chemical Society, both of them are very committed to having a lot of resources available for chemists and for librarians to use their products. And so SciFinder, which is the main channel, most people use chemical abstracts online. There's many webinars, there's podcasts, there's RSS feeds. You name it, they've created it for training on SciFinder. So I find as a selector, I very rarely have to create any of those materials myself. I almost always go directly to those sources. Reaxis, which is the online database for Beilstein Crossfire, that has a lot of resources as well. It's now owned by Elsevier, but it was previously owned more collectively through the University of Wisconsin. And so ChemSpider, which is a free database, which has been available for several years now, it was originally independent on its own site, and then it was acquired by the Royal Society of Chemistry, I believe, in 2009, if I'm not mistaken. They also have a lot of basic information on searching and how to find things, and training materials as well. So if you do need to learn more about these databases, if you become a selector, there are sources that you can use to do this. Okay, so I'm just going to check the time. So I'm doing fine for time. And so the other tool, of course, is you'll need to buy books. And one of the characteristics of chemistry collections is that there are fewer books published, but they tend to be significantly more expensive than, say, areas of the social science or humanities, and even within the sciences. So it is more important that you get, bang for your buck, so to speak. And a few purchases could total, a significant part of your collections budget for books. So I've included some sources here on where you can find book reviews. I mean, chances are, if you're becoming the chemistry selector, you don't have anyone else in the organization who may have selected before. So you may feel very much on your own in that sense. The Journal of Chemical Information and Modeling has reviews for software. It has reviews for books, and a lot of reference material, so it's a very useful source. I think it's published quarterly, so it doesn't come out quite as often as some of the other sources I mentioned here, but they are very chemistry specific. Library Journal has book reviews that are published in each issue, and it also has these bestseller lists, which I've pulled here from their website. I usually check those bestseller lists to see what titles we might want to add to the collection that may not come on my Google Plan profile, for example. And then I can also search in Library Journal for the individual book reviews. I myself have been a reviewer for Library Journal for a while, but I haven't reviewed very many chemistry sources. I mostly reviewed math and physics. So I'm a little bit less familiar with those individual titles in Library Journal. You can also, of course, use Amazon. Many people review books in Amazon, and you can get good information about the book. Many times you can find out whether the revised edition is really as revised as they say it is, because sometimes that's an issue in science books and collecting in that area. And then there's also some other sources. Choice has science books, although honestly I haven't looked at a lot of reviews for Choice, so I'm a little bit less familiar with that. And then there's also sources online. For example, Issues in Science and Technology and Librarianship has various bibliographies, as they call them, on different topics. The one for chemistry that I've shown here is from 1998, so it's a little bit older. It's by Chuck Huber, who's at UC Santa Barbara. He's a chemistry librarian there. He's pretty well known in the chemical information community in the ACS. And so there's other bibliographies in other areas. There's one on nanotechnology. I believe there's one for engineering. There's guides for related sources that are a little bit more current. So those are useful tools for the print collections, but you'll also find that it's useful to read about what people are doing in the real world. And so some of the blogs that I've posted here are examples of those. Peter Murray Rust is another active chemical informatician, and so he has a blog, Peter and Lars blog. I don't know if you're familiar with this blog, but he also posts about scholarly communication issues. And so he had a really nice series of posts about the economics of information and how it's changing and how it's impacting scientists and what they do. The Chem Connector is the blog of Anthony Williams, who runs ChemSpider. There's also a separate blog for ChemSpider. And so he'll talk about different issues, mostly with structure searching and developing tools for finding information more quickly. Another useful, interesting blog is there's a blog on Open Notebook Science by a chemistry faculty member, Jean-Claude Bradley at Drexel University. And so he talks about the challenges of making your research record completely open from the day you walk into the lab to create the data until you finally published it online or in a book or in a paper or electronic source. Another chemistry blog which is useful is ChemBark, which is by Paul Brocker at Stanford, I believe. And so he talks about a lot of various issues in the chemistry community, in the research community, mostly in academia. And so he has an interesting perspective as a postdoc and a practicing chemist. I'm pretty sure he's either an organic/inorganic chemist, so he definitely is in the lab doing a lot of experiments. And he does talk about chemical information issues while he's talking about his other things. And then another blog, which has not been active for a while, but has talked about scholarly communications and collections, and pretty much the future of some of those issues is the Book of Trogle. I blogged for that for a brief period of time. I haven't been blogging for that lately. So there are some things about chemistry collections there. So that's the community information. As you can tell, there's quite a bit of that. So I'm going to talk a little bit about selection advice and some of the things I've learned over the years. The guide talks about the basic things: time management, publishing cycles, dealing with approval plans, which as a selector you may or may not need to adjust when you're doing that, dealing with interdisciplinary work. But I wanted to show you a few of the things that I thought were useful as well here today. One of the things I would recommend is to read reviews. I mean, I think most people write fairly accurate reviews and have a lot of good information. Like I mentioned back at the slide with the reviews, I tend to look at the sales and other libraries' holdings data to decide if I want to buy something or if I should purchase something if we get it as a gift. Looking for discounts is always a good idea. Our YBP contract gives us a discount for each individual purchase, so you want to make sure you're getting that when you can. And then I would say don't be afraid to buy ebooks, especially for reference. I've found that chemistry is a discipline. They're very comfortable with electronic materials, and in most cases they'll be more comfortable with them than you might be. So buying an ebook is usually money well spent. So my next slide here, I'm going to have a caveat. These may or may not be actual pieces of paper that I've used in my own collections work, but I've tried to develop systems for tracking my expenses throughout the year for the different collections I cover. I still keep it on a piece of paper in a folder, and I update it manually, but you could certainly do it on an Excel spreadsheet if you wanted to. And I also keep an ongoing list of faculty wish list items with who requested it and how much, where I got the price quote from, because depending on where you get the quote from, you need to go back again to get it updated. And so over time, as you do this more often, you'll have a longer list and a deeper history of what people are requesting and what they might want to have in the collection. Another piece of advice I have is that junk mail is usually pretty useful if you're a new selector. I dug this out of the trash last week when I was making this presentation. And so usually you can get information on new editions of classic works that are probably already in the collection. And also if there's new sources that are coming out that you may not have heard about before, the publisher will usually promote them through pamphlets. You'll also get emails. I mean, I just scanned the front page of this print source. I would say it's more common now you're going to get an email from a publisher. And so interdisciplinary work in chemistry is becoming more important. It is throughout all of the sciences. These are some screenshots from YBP in the Gobi selection system. I'm not sure how many of you are familiar with Gobi or use it already for your approval plans or selection. But there are interdisciplinary topics in Gobi that you can search. On this screenshot here, it shows there's one for nanotechnology. So if that's an area that frequently chemistry, physics, engineering covers as well. So if you need to search for things in nanotechnology, that's a good way to do it. You can also do a search through title searches, and series titles, and subject titles. This screenshot shows all of those different types of searches in Gobi. I tend sometimes do a subject search on nanotechnology or material science because I'm also the material science liaison. That's a good way to pick up some titles that you wouldn't normally get through your profile plan. Okay, so that's a little bit about selection. I think the other general guidelines for selection would apply to chemistry as for any other subject, so I didn't really cover that in this webinar. But certainly there are things on the horizon for collections in all areas. And for chemistry specifically, there's some really interesting things going on. And so I'm going to talk about them now. One of the areas that's really evolved quite a bit in the last few years is finding more robust ways to search for chemical information on the internet, specifically the web. And one of the problems is that if you have a chemical structure, and I have cyclohexane here as an example, you know, a chemical structure can be represented a lot of different ways. And this picture shows you've got different graphical representations. There's two three-dimensional structures. There's also a CAS registry number, which is the substance identifier number in chemical abstracts, which is the main chemistry research, article database. And then you have other identifying numbers. Get my cursor back there. It is. So you can see their ChemSpider has its own identification number. There's one in PubChem. There's one in DrugBank. There's also these SMILES and INCHI resolver codes or search strings to identify the structure. So because of this, it can be very hard to find a comprehensive set of information about a structure. And so these INCHI keys, INCHI resolvers, the SMILES resolvers, all of these have been developed fairly recently to provide that way of searching online in a database. And for example, you could take an INCHI search string. I didn't put one on the screen, but it's a string of numbers. It's almost like a DNA amino acid code, like AATTCG, similar to that. It's a character string. It's not a picture. You can put it into the web and search for that INCHI string, and then you can pull up that structure. And so you could pull up, say, an orientation structure, which would be unique, say if it were oriented in a different direction, or a specific isomer, or a specific ion, or chemical representation. So you can have a more robust search, a more specific search, and you don't have to go through these more complicated structure drawing tools. This is an area where there's been a fair amount of development. This screen here on the left is from Wikipedia. And Wikipedia has done an interesting project where they've been integrating more of that data into these social media sources and providing verified checking of the information to make sure it's correct. For example, this structure here, you notice next to the CAS number and the UNI number and those different identifiers, there's those green check marks. That means that those numbers have been verified in another source like ChemAbstracts or Biosis or Medline or the GenBank database, for example, that they're verified and correct. So I know many people are frustrated with Wikipedia and may feel it's not accurate. For a lot of the chemistry information in the chemistry portal, which I'll mention later on, it is correct and it's verified, and it's pretty close to searching something, say, in chemical abstracts. And so to go along with these identifiers for structures, there's also been more broadly an emphasis on providing author identifiers. And so some of those examples are at the bottom of this text here. ORCID, which you may have heard about. There's researcher ID from Web of Science or Thomson Reuters. And Scopus has an author identifier number as well. And you can see I have my own author identifier number in Scopus on the screen here. And all of those 3 should be available free on the web. I don't think ORCID has all their numbers finalized, but for both Researcher ID and Scopus, you can find those on the web. So integrating free and licensed content is becoming more important, just like I mentioned in the last slide. You can see that there are APIs being developed to search tools. I mean, this is true outside of chemistry as well. There's the Wikipedia chemistry portal, which I mentioned. The Open Notebook Science is integrating these free sources and licensed sources. There are sites like Figshare, which I show here, where you can post your raw data that you couldn't necessarily put in a paper. Maybe the experiment didn't work, or as you thought it would work, things like that. And so ChemSpider, I have an example here too. There's an API for mass spectra, which is another form of spectra that you can search. So all of these APIs and the specialized search tools are going to become more important in the future. So as you might expect from these integrated tools, there's going to need to be more sophisticated web applications to embed and link data together. And so we're at the beginning of this in chemistry. Chemistry is actually a little bit behind because of the proprietary nature of materials. But a couple of examples of semantic or added value applications are Project Prospect from the Royal Society of Chemistry. They've taken some of their journal articles and they've embedded Dublin Core metadata into them, which you can see on the left-hand side. And they've also integrated, for structures within an article, they've integrated these INCHI resolver codes. So you could go and click on that INCHI resolver code or that Dublin Core metadata, and you could go back to other sources. And so you can link to other material in the database. It's also useful if you are creating institutional repository because they already have the Dublin Core metadata created. And I don't know if you're familiar with institutional repositories or creating electronic collections for print collections, but frequently you'll have to create your own metadata for them. So I think we're going to see more cases where the metadata has already been created. And then for chemistry, Microsoft Research has created a chemistry add-in where you can create structures and embed chemical information in your documents. So as you might expect, because things are becoming more shared outside the library, within the library that's happening too. And you're probably familiar with some of these more general collection sharing projects that have occurred, the 2CL project in Columbia and Cornell. I'm in the SUNY system in New York, and so within our system we've been sharing monographs from university presses for a while. And then more recently, just the sustainability of library resources and cost of library resources. I'm sure most of you are familiar with the Harvard Library Council's statement on journal prices and how unsustainable they are. So I think we're going to see more development in this area. I think more people are going to share more collections. And maybe more libraries or more faculty will say costs are unsustainable. Another collection tool which will be coming out, which I found out about earlier this summer, is there will be a new chemical information sources textbook or monograph created from the Royal Society of Chemistry. The editor is Judith Carano, who is the chemistry librarian at the University of Pennsylvania. And from what I heard, I didn't have a web page to go to, or I don't have anything official, but I had heard it was going to be published next year. So I think this will be an updated version of these previous guides that we've talked about, and it will certainly be a good source for selection as well. So I've showed a few highlights from the guide. I've gone a little bit over time, and so there's the print guide here. And so I am happy to take any questions that you might have from this. And I just wanted to, I have a slide here thanking a few of the people that helped me with this, my colleagues and locally and nationally, and also the people at ALCTS, Doug Litz and Helene Williams were the editors, which helped me with my guide. So I just wanted to thank you, and I have any, I'm here to answer any questions that you might have on the screen. I don't see anything listed here in my window box, so feel free to type in a question if you like.
Okay, we do see some typing. I don't think we have any full questions yet. Beth, while we're waiting, in the presentation last week, Flora, when we were talking about biology, was talking a bit about the eigenfactors and the impact factors of citations. Is that something that still affects your work in chemistry as well?
It does. I didn't go into the citation analysis part, since it's a little less focused on selection per se. But yeah, chemists are very, they live and die by their citations, and so they very much look at the Web of Science citation data for their work. I would say they are overall a little less interested in the alternative metrics. Eigenfactor is one of them. I mean, there's also some others that have, like the H-index, that have come up. So yeah, I would generally say chemist, you will hear about citation numbers if you become a chemistry selector.
Okay, we did get some questions in. Somebody wanted to know about the opposite of selection. How would you weed a collection?
Okay, well, I actually did that in my library a while ago. I didn't do it a few years ago. I'd say I started that. And what I did was, there's a source that I used, Nan Vukovic from Penn State University. She did a study on determining, like, say, the research lifespan of materials, or say the active research lifespan. And she found that chemistry materials were used for about 20 years after they were published. And so what I did, I used this criterion stacks for the books. I looked at things that hadn't circulated in 20 years and were, you know, over a certain, they obviously had to be over 20 years old, or maybe. And so that was what I used as my weeding criteria for the books. And I was surprised when I went through the books, because I looked through quite a few of them. Most of the books were either checked out a lot or not at all. So it was actually pretty easy to decide which books needed to go.
And did you look at holdings at other libraries when you made some of those choices, or did you do it just for your organization? Were you looking at the SUNY collection?
In some cases I did. There were some things, though, I didn't withdraw. I just sent them to our offsite annex facility or offsite storage. I tried to save older conference proceedings. And I tried to save things that, you know, looked like they had some kind of historical value. And I'm trying to think what they might be. In some cases, if they were anything that had a local connection, like say if the faculty member that wrote the book was, you know, in the local area, or it was a topic that you know, so they weren't an active faculty member, they'd retired, that sort of thing. I found it was usually fairly easy to make a decision, though.
Okay. For your return on investment for things like recruiting students, do you work with admissions to promote the extent of your chemistry materials? Do you use it to support budget requests from administration?
In some cases I have. I mean, I think more broadly, though, sometimes people want you to search for citations and to help. Like, say if a faculty member is developing a portfolio for a promotion and tenure case, they might ask you for, okay, how many citations did I get for all my articles? Am I doing it right? And, you know, which ones are the top journals I should be emphasizing, that type of thing. I think that's a common thing that chemistry librarians will do. And I've also given class sessions in the chemistry classes for their senior seminar class. So I have had different interactions with administrators and students and things like that.
Mm-hmm. Are there any chemistry-focused open access journals of note that you'd like to mention?
There's a few. There's a few. Maybe I should send a link with those afterwards.
Yeah, we can do that if you...
There's not that many, though. I mean, there's a few. Yeah, why don't I do that afterwards?
Okay, that sounds good. We'll send that off to the ALCTS office, and that'll go out in the email.
Okay. Yeah, because there's a few, and say Biomed Central and Chemistry Central have open access content, which I didn't focus on here. So I'll send that.
Somebody else would like to know the size of your monograph budget and how many students or graduate students, undergrad and graduate, you have in the chemistry department at Binghamton.
Well, how big are we? Let's see. I would say we are a smaller. We're in between a small and a medium department. I would say we have about 20 maybe 20 faculty. And I would say about 70 grad students. And chemistry is a popular undergraduate major here, so I think we have about 100 undergraduate majors. So our total student population is about 15,000. So I think we're a little small for a school of that total size, but we're not, tiny, tiny.
Okay, well, we probably have time for one more question if someone's got it. Otherwise, we're going to go ahead and wrap up here. I'll just give one more moment. Okay. Somebody would also like to know how much you think you've spent on monographs. Maybe what's your yearly budget?
Oh, what's my yearly budget for monographs? Well, I went through one slide that had some data on it, but I think I have about $20,000 a year to spend. I'm thinking it's about $20,000 for chemistry. And I also have other subjects besides chemistry, so I sometimes, if it's related to other areas, might purchase it on that. I would say for the size of our library, we have a pretty healthy book budget still. I know of colleagues at much larger institutions that don't have as much money to spend for books as I do. And so there's various reasons for that. I mean, our collection, Binghamton University was founded as a liberal arts university, so that's partly why. And I'll just add, too, I also have money for standing orders as well as my, regular one-time orders. So it supplements the budget a little bit, but we've really evolved from having more standing orders to fewer standing orders. We've been putting more things. We've been migrating things from standing orders to, say, approvals and firm orders in the past maybe 2 to 3 years.
Yeah, I think we've seen a lot of that.
Okay, and I think I'm assuming that's pretty standard in most places.
Yeah. Well, okay. I think our time is up for today. So if anybody does have additional questions, you can certainly contact Beth directly. I want to thank you, Beth, for your advice on starting out as a selector. It was a great mix of community sources, some online stuff, some social media, so that was all really great to look at. I'd also like to thank all of our attendees who were with us today. We hope you found today's session useful. You'll receive soon afterwards an online evaluation form. Please take a few minutes to respond to the questions and return the form to us. We do use your comments, and they do help the ALCTS Continuing Education Committee to plan new offerings. Information about all ALCTS Continuing Education offerings can be found on the ALCTS homepage under Online Learning, and I have the link here on the screen. There are about 12 more webinars scheduled through the end of this year, as well as online web courses and monthly e-forum discussions. Our RDA series is starting up again on September 12th. And actually, August's e-forum discussion list started today. It runs today and tomorrow, and that topic is turning statistics into assessment. How can technical services measure the value of their services? And it's been a really interesting run so far, so there's been a lot of nice communication on that. We're also building our 2013 calendar, so any suggestions for webinars or other continuing educational opportunities are welcome at any time. You can contact me directly. This is Carrie Cassio, Chair of the Committee, or you can submit a proposal for a webinar using our online forum on the website. I'd also like to thank Felicity Dicus and Jane Rosario for providing our technical support today, as well as Julie Reese and Alyssa Novak in the ALCTS office. Our technical support experts make it possible for us to present these webinars smoothly. So thank you for joining us this afternoon, and we hope you'll participate in other ALCTS continuing education events in the future.